Okay, welcome back everyone. In this video we're going to talk about the four-step problem-solving method. And when you're solving physics problems, there's lots of different ways to do it. Your book has a particular method that it describes, but I like showing students this method. I think it's pretty simple, easy to remember, and it applies to just about everything that we could do. So I'll just go through these steps and then I'll show you an example. So the first step is to read the problem, draw a diagram, and try to identify the givens and unknowns. The second step is to figure out which physics equations should be used, and this probably depends on what physics principles that the problem's looking at. For example, you're probably watching this video during our unit on distance and displacement and velocity and acceleration. So those are probably good concepts to look at for solving those types of problems. So in the second step, we need to figure out what equations to use, and we're going to use algebra to solve these for the wanted variables. In other words, when the equation is pretty complex, we're going to rearrange it first. Then we're going to plug and chug to figure out the answer, and we're going to keep an eye on units. We're not going to write units for every step because that's annoying, but we'll try to think about what they should be, and we'll try to keep track of sig figs. And then the last step is to evaluate the answer. Is it reasonable? Does it make sense? For example, if you get a speed that's 5 times the speed of light, you might know that things can't go faster than light, so that doesn't really make sense. Okay, so here we go. Here's an example. I think this is one of the homework problems. I'm not sure what set it's from. A ball is thrown straight up at an initial speed of 9.8 meters per second and, on returning to your hand, hits it moving downward at the same speed. If the whole trip took 2.0 seconds, determine the ball's average acceleration and average velocity. So let's look at that first part to find the average acceleration. And we look at our four-step problem-solving method. Step 1 is to draw a diagram, identify the givens and the unknowns. Okay, so here's the ball, and it's thrown up with an initial speed of 9.8 meters per second. And then we also know that when the ball comes back down, so it's going to go up and come back down. And when it gets to the same height, it's going to be traveling downwards, and that's a final speed of 9.8 meters per second, and that's down. So we could say, and this is a good idea for most problems, we could say that anything going up is identified as positive and anything going down is negative. So this is a positive 9.8, this is a negative 9.8. Okay, that works. So let's see, what else can we identify? Well, another given is that the whole trip took 2.0 seconds, so the time interval is 2.0 seconds, and we're just trying to find, in other words, the unknown is the average acceleration. So our unknown is a equals, we don't know. Okay, so this is the diagram and the known quantities. This is the unknown, and that pretty much is step 1. Step 2 is we have to think, okay, what equation is going to have acceleration, final and initial velocities, and time? And it turns out, so I'll just kind of label this for us, this was all kind of step 1. Step 2 is the equation that defines acceleration. And the definition is acceleration is a change in velocity, so I'll put a vector on it, divided by a change in time. By the way, if you're unsure about the little arrows, make sure that you look at the video about vectors. And we know that a change in velocity is v final minus v initial over the change in time, and that's the second step. Okay, so we're going to identify the correct physics principle or equation. We're going to write it. Now what we would do is, if we had to, we would rearrange. Okay, so we would rearrange, or we would solve the equation for the acceleration A. But it's already solved for acceleration, so we don't have to do that. So in a later example, or on another problem, you might need to solve this for the final velocity. So you could start with this equation and then say, oh, I could multiply each side by t, and then I could add v initial to each side, and that could get me the final velocity. Okay, but that's for something else. Right now we're just trying to find the acceleration. Okay, so step 3, if you remember, is to plug and chug. And one nice thing about rearranging is that you don't have to put in the units and keep track of them for every single step. You just put them in once and you're done. So here we go. Acceleration is equal to v final. Okay, now v final is negative 9.8 meters per second. Okay. Then we have to subtract v initial, which is positive 9.8 meters per second. Well, that doesn't matter. We're still going to be subtracting it. Whoops. Let me try to get rid of that. Okay. Sometimes the stylus doesn't work so great. Alright, and we want to divide by the time interval, so that's 2.0 seconds. Okay? So here's where the plug and chug comes into play. That's going to be negative 19.6 meters per second divided by 2.0 seconds. And now we can find our final answer. Okay, so negative 9.8. And what are the units? Well, don't be tempted to cancel out the seconds. They don't cancel out. Because we have acceleration, it's going to be meters per second squared. Okay? So that will be our final answer. And one thing that we can do to see this is, if you take meters per second and divide by seconds, that's meters per second times 1 over seconds. So that tells us meters per second squared. Okay, and now for the final step, we're going to kind of think about, right, does this answer make sense? So we're going to evaluate the answer. Okay? So this step is evaluate. Well, at some point we're going to learn that objects in free fall, in other words, objects that are moving, that are only acted upon by gravity, have a vertical acceleration of negative 9.8. Okay? So since the acceleration of free fall is negative 9.8, it makes sense. So our answer makes sense. And there you have it. There's the basics of how to do 4-step problem. Now when you watch other videos on how to do different types of things with motion problems and kinematics, I'll be following the 4-step method, at least for a while, so that you can kind of see it multiple times.